So far, we've learned to solve systems of equations by graphing and seeing where the lines intersect, or by using substitution, where we solve for one variable and then substitute an expression in for that variable. Here, we're going to learn about a third method for solving a system of equations by either adding or subtracting the equations so that one of the variables cancels. That's our goal. And if you take a look here, you can see that the variable y, these have opposite signs. So if we add these equations together, the y's will add to 0 or cancel. 5x plus 3x will add to 8x. And on the right side, 12 plus 4 will add to 16. In other words, we had two expressions that were equal, so we added that to the left side of the one equation and the right side of the other. Now to solve for x, we would take 16 and divide by 8. We would get x equals 2. But remember, we're not done yet. We need to go back and figure out the value of y. So I'm going to use our second equation here. And I'm going to take 3 times what we just found for x, which is 2, plus y equals 4. So you have 6 plus y equals 4. And subtracting 6 from both sides, we have y is equal to 4 subtract 6. That would be negative 2. And it's a good idea to substitute these into the other equation just to make sure they work. So let's do that. Here's our check. Our check will be to do 5 times the value of x, which is 2, minus the value of y, which is negative 2, so we'll have to be careful of our signs here, and see if that really does equal 12. So 5 multiplied by 2, we have 10. Subtract a negative 2 is the same as adding a positive 2. And so it's very easy to see that 10 plus 2 is equal to 12. So we know that this is the solution. We know that the solution is the ordered pair, 2 for x, negative 2 for y. So this system was solved by adding the equations together. Let's take a look at an example where we're going to subtract the equations. Notice here that 6c occurs in both equations. So if we subtract the equations, and I'm just going to make a note here that we're subtracting, that if we subtract the equations, 6c subtract 6c, those would cancel. 7d minus a negative 2d, we have to be very careful here. 7d minus a negative 2d would be 9d. 7 minus a negative 2 is the same as adding a positive 2. And then, once again, we have to be careful here. Negative 15 subtract 12 would be negative 27. So be very, very careful with your signs here. Dividing by 9 would give us d is equal to negative 3. But once again, we're not done. We need to go back and substitute the negative 3 in place of d. I'm going to use the first equation. So we'd have 6c plus 7 times what we just found for d, which is negative 3, equals negative 15. And so simplifying here, we have negative 21. And then we'll add 21 to both sides, so we'd have 6c equals 6. Be very careful of your positive and negative signs when you're working with adding and subtracting positive and negative numbers. And then dividing both sides by 6, we get that c is 1. Once again, we're going to check by substituting into the other equation. So our other equation is 6 times c, I got 1 for c, minus 2 times what we got for d, which is negative 3, equals 12. So I'm using this equation right here and substituting what we got for c and d in place of c and d in that equation. So 6 times 1 would be 6, minus, and 2 times negative 3 would be a negative 6. And is 6 minus a negative 6 equal to 12? It is. So our solution is correct, and if we want to write that as an ordered pair, we'd have 1 for c and negative 3 for d. If you have any questions on this screencast, you should be able to get a little help from the sub in class tomorrow, and I'll be able to answer all your questions also when I get back. Thanks.